Okay, so we are going to start looking at how to classify different triangles. Much like we did with line segments, angles, there's a couple different ways that we can do this. To start off, I want to refresh our memories on how to name sides, vertices, and angles of a triangle. So one way that I am going to name the sides is just like I would name a line segment. So I'm going to say I have segment side AB, side BC, and side AC. We'll remember from line segments, does not really matter what order we do that in. I could also have said BA, CA, and CB, but I'll leave it like that. Vertices, those are these points where all of them meet at. So my vertices are A, B, and C. And my angles, remember, it does matter how I name those because I want vertice right in the middle of it. So I'm going to say this triangle is made up of angle BAC, which is right there, angle ACB, which is right there, and angle ABC, which is right there. And again, we can name those different ways. Just got to make sure that vertice is hanging out in the middle. Okay, moving on. The next way that we are going to be able to classify these triangles is classifying it by angles, which you'll see on the left here. The first one that we're going to classify it by is as an acute triangle. I can say a triangle is an acute triangle if all of its angles measure less than 90 degrees. A lot of these things should be familiar to you, so that's why I'm going pretty quick through them. They should be pretty familiar. Right underneath that, if I put that right there, I'm going to say this is a right triangle. That one should probably be the most familiar. We've already worked with it a little bit this year. For this guy right here, I'm going to say all three of these are equal. All three of those angles are equal. If that is the case, I'm not going to call it an acute angle because all those angles are acute, but I'm going to call it an equiangular, which might be a little bit of a new word for you. You probably typically looked at that as an equilateral, which it is, but if we're specifically talking about the angles, I'm going to say it's equiangular. And then the last one you may have guessed, for example, if I have that as 100 degrees, this is an obtuse triangle. Over to the right, we've got classifying by sides. These should be very familiar. You've been learning about these for a while. If I've got three sides that are not equal, remember this little notch mark, if it's on two same lines, that means that it is congruent. So if I mark it in this way and I say I've got one notch here, two notches there, three notches there, all of those sides are different measures, so that's a scalene triangle. To the right, I'm going to say these two are equal, and this one is not. That is isosceles. Hopefully you can read that. Oops. Isosceles triangle. And then the last one, like we said before, if I have all of my sides equal to one another, that's an equilateral triangle, if I'm talking about the sides. So that should all be pretty familiar to you. Let's take a look at this down here. Triangle sum theorem. Also something that I think we all know. All three angles of a triangle always add up to 180 degrees. You might not have called it the triangle sum theorem, but now we've got a name for it. So in this first example that I've got, if I say this is 36, this is 102, and this is angle 1, how am I going to find the measure of angle 1? So, the way I'm going to do it, I'm going to say 102 plus 36 plus the measure of angle 1, I'll call it x, is equal to 180. Because that's what my theorem tells me. And that's just from what we know about triangles already, we know that. So next thing I'm going to do, I'm just going to solve that like a regular algebra problem. And when I do that, x is equal to 42. So the measure of angle 1 is 42 degrees. So, moving on to the next one. Cross out this z thing. Actually, I'm probably going to have that crossed out in your notes when I give them to you. But for this next example, I'm going to say this angle is 65, this is 39, this is x, this is 21, this is y, and this is 41. I'll give you, take a second, pause the video, write down those measures so you're keeping up. Okay, so I can use my triangle sum theorem to figure out x and y, and I'm going to do it separately. At least in this case I am. It's not really much different than the first example. I'm going to say, okay, to find my x's, I know that left triangle with the x in it should equal 180 degrees, so I'm going to say 65 plus 39 plus x equals 180. And then I'm going to solve for x. And when I do that, x is equal to 76. And then I do the exact same thing to find my y's. My triangle on the right has the y's. I'm going to say 21. Let me actually write it in a different color so we're not confused. So I'm going to say 21 plus 41 plus y equals 180. And then I'm going to solve for y. And I'll get y equals 118. So up here I've got x equals 76 and y equals 118. So let's go ahead and flip the page. And I want you to try this one. Let me give you some angle measurements to work with. I'm going to say this one is 2x plus 14. This one is 2x minus 9. And this is x. Using the triangle sum theorem that we just did, we were working with more numbers before, see if you can figure out what x is equal to. Okay. Once you're, hopefully you have paused the video and done that. Let's look at quadrilaterals now. Remember, quadrilaterals have 4 sides, 4 angles. Also should be pretty familiar with these. The quadrilateral rule is all 4 angles of a quadrilateral add up to 360 degrees. Kind of like a circle. So I'm going to use that the same way I use my triangle. If I say this is 125, this is 100, this is 55, and this is x. I'll give you a second. Pause the video for a second so you can write down those measures. I'm going to set those up just like I set up the triangle sum theorem. So I'm going to say 125 plus 100 plus 55 plus x equals 360. And then I'm going to do that math out. X should equal 65. And if I do that check, I make sure my math is good. 225 plus 50, yep, checks out. If I add all those together, because now I'm saying, okay, just kidding, that's 65. Should all equal 360 degrees. So now you give it a try. I'm going to tell you this is 100, this is 60, this is 135, and that's x. Find the value of x. Pause the video and get that done. Okay. Let's take a look at this last page. Our last theorem that we're going to look at in this video is the exterior angle theorem. Exterior angle theorem says the exterior angle is equal to the sum of the remote interior angles. Now when you think of remote, you can think of it in a couple different ways. If somebody says they work remotely, that typically means they do not work where their office is. They work away from it. They don't work in the office, they work remotely. That's something that might not be really what you're thinking at this point in your lives. So here's another way to think about it. If I've got this angle right here, I'm going to say my TV is there. There's my TV. Now typically the point of having a remote for your TV is so that you're not right next to it. You don't have to be right on top of it. You are away from it. So maybe I'm sitting at this angle and watching TV. Or I'm sitting at this angle and watching TV. These two are my remote angles. They are away from the exterior angle. This is my exterior, where my TV is. You'll see it's outside. I'm talking about the angle outside of the triangle. And these are my remote. So my setup, they're going to look, let's see. I'm going to say X right there, that's my exterior angle. My remote angles are 99 and 22. My setup of this problem, let me look at what my theorem says. It says the sum of the remote interior angles is equal to the exterior angle. If you say that out loud, that's your problem setup. The exterior angle X is equal to the sum of the interior angles, which we just said were 99 and 22. So that angle is, what is it, 121? 99 plus 22? So that exterior angle is equal to 121 degrees, using that theorem. So let's do one more example, and then we'll give you one more to try. So if I say this is x plus 14, and this is 70. I need to be able to, and we've been doing some work with this, I need to really be able to start getting good at recognizing supplementary relationships. I've got a straight line there. So if I know that this is 70, I know that this guy right here is 110 degrees. And I know that because of supplementary angles. Because in order to use the exterior angle theorem, that's the angle that I want. That's what I want to look at. So okay, I got that now. And now what I want to do is I want to use my exterior angle theorem. I want to say x plus 14, my remote angles. The sum of those is equal to the sum of my exterior angle, 110. And then that just becomes solving just like a regular algebra problem. X equals 48. The last one I'm going to have you try on your own, and I'm going to do it kind of similar to how I did that first example I gave you on the other page, where it's going to be a little bit trickier. I'm going to say this bottom left angle is 9x plus just 9x. This one is x plus 2, and this guy right here is 3x minus 13. So go ahead and give that a shot. And that concludes our video for today. We will talk a little bit more next class about some of those you-try problems that you did. And we'll get some more practice with finding exterior angles and angles and triangles and all that good stuff.